living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. The heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. Screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The streetways are wide, to the world where we glide. From the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. heart of the galaxy where the stars align. We gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Gaia spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hello, my name is Javier Mancho. I'm from Madrid. I'm finishing computer science at the Universidad Francisco de Vitoria. And today I'm going to present you the AI side for my project, Voice-Driven Robot Goal Assignment System with Liquid Galaxy. First of all, I want to introduce you to the project goal, which is to create an interface that allows users controlling different robots using voice commands. These robots will be distributed in different areas and can be selected using a mobile Flutter application. So the project architecture is as follows. We have the client side with the application and the Liquid Galaxy system. Then the server side, which is the different modules. In this case, it has the LLM, the speech-to-text model, and the decision-making algorithm, and then the robot. Starting with the process, we have the speech to text, which is in charge of transcribing the audio file recorded by the app. This audio file will be sent to a model in a wave format and will return the transcribed text. This model is based on a neural network, which is in charge of transcribing the audio by detecting the phonetics and linguistic patterns. To do this project and to simplify it, I'm gonna outsource the model using the Google speech to text, and yeah, the output will be passed to an LLM, which follows this structure. We have the pre-trained LLM, like Gemma 2 or Gemini 1.5, and then I'm gonna build a data set which is based on an input with natural instructions like the move the robot X meters to the right or stop the robot or something like that, and then the output will be the PDDL problem, the Planning Domain Definition Language problem. This all combined, doing LoRa technique. I'm gonna get the fine-tune LLM, which is specialized in transforming natural language to PDDL problems. I believe that it is a way better technique to use because the pre-trained models doesn't solve accurate these problems. So this is the workflow. I have the input, move the robot 10 meters to the left. Then the new model will construct this output, which is the problem file with the domain, the objects, the initial state, and the goal state. Then, moving on, we have the decision-making algorithm. This is the symbolic AI side, where I'm gonna use fast downward, which is an already working framework to do planning. And this framework uses the domain file and the problem file, and by doing search, it finds the solution. For this project, I'm gonna use A star, which explores the state space using heuristics, and I believe that it works well with the context of this project. So last, we have the complete workflow to synthesize the whole flow, where we have the client, where the user recording the audio to the mobile phone. The mobile phone sent the wave file to the server. Then using a post request, I'm gonna send the file to the Google speech to text model, which returns the transcribed message. Once the transcribed message is received, I'm gonna send it to the LoRa fine-tune LLM to construct the problem file, and combining it with the domain file, I'm gonna pass it to the fast downward to return the set of actions. And that's it. That's all my AI side for my project. I hope you find it well, and see you in next phases. Thanks.
Hello community, I am Karan Kumar Das from Kolkata, India, and currently I am pursuing my BTech in Computer Science and Engineering at IIT BHU Varanasi, and I am super excited to be part of Google Summer of Code 2025 and contribute to Liquid Galaxy with my project Google Labs Generative AI Data Visualization. The goal of this project is to build a web-based visualization platform that lets user interact with Liquid Galaxy through natural language prompts and voice commands. User can simply ask questions or give instruction, and the system will automatically generate and display the KML on Liquid Galaxy screens. This project will be built using HTML, CSS and vanilla JavaScript for the front end to keep it lightweight and framework independent. And I will be creating a separate backend with Node.js and Express, where I will integrate LangChain.js with Google Gemini model to handle prompt processing, context management, and AI responses. For voice input and output, I will be using the web speech API for a hands-free interaction. The generated KML files will be synced with Liquid Galaxy screens via LG Server API calls, and additional features like file uploads and QR-based rig pairing will enhance its flexibility and usability. Now, let me be honest, this isn't just another front-end UI or data viewer. Uh, Here is why this project really stands out. Uh, the first thing is AI based interaction. You talk to the app like you are chatting with an assistant. It uses LangChain plus Google Gemini to understand your prompts, figure out what data you want to visualize, and then builds the right KML for Liquid Galaxy. No need for technical knowledge, yeah, anyone can use it. Automatic KML generation and visualization. The AI does not just reply with interaction; it builds the right KML code behind the screens and then syncs it directly to the Liquid Galaxy rigs via the LG server via the LG server API calls. Uh, for talking to the accessibility, the platform speaks back to the AI responses to the users using text to speech, making it super accessible. This can be really useful in classrooms, museum, or exhibition where hands-on control isn't always possible. Now I will talk about how the AI part works. Basically, how everything works behind the screens when a user interacts with the app. The very first thing is understanding the user's prompt. The user starts by either typing a message or speaking a command using voice input thanks to the web speech API. This raw inputs needs to be processed in a way that the AI can understand not just the word but also the context, especially since we are working with a specific system like Liquid Galaxy. The next thing is prompt engineering with LangChain. Here is where LangChain.js comes in. LangChain allows me to structure and enrich the prompt before it's just sent to the AI model. I use something called prompt template in LangChain where I inject system level instructions and context. For example, what Liquid Galaxy is, how KML works, what kind of outputs are expected, and what kind of visualizations are supported. This ensures that even if the user gives a vague or incomplete prompt, the AI still knows how to respond accurately because the template guides it. The next thing is AI response via Google Gemini. Once the structured prompt is ready, it's passed to the Google's Gemini model, one of the latest large language models optimized for reasoning, creativity, and even the code generation. The model then processes the prompt and gives one of two kinds of output: a textual response if the query is general or informational, or more importantly, a KML code block, which is ready to be displayed on the Liquid Galaxy screens. This is the most exciting part where the AI turns a natural query into real time geospatial context. After generating the KML code, now it's time to automatic visualization in Liquid Galaxy. Once the KML is generated, I will use a custom tool inside LangChain to send it to the LG rig. This tool is integrated with LG Server API, which allows my backend to communicate with the Liquid Galaxy system. Using LangChain's bind method, I connect the tool to the AI agent so that whenever a KML is generated, it gets sent and visualized automatically. No need for the user to manually copy or paste anything. To make it more robust, I've also added a sync to LG button as a fallback, so users always have the control. If somehow it not synced with the LG, Liquid Galaxy screens. Now the very interesting thing is conversation memory with LangChain. One of the key things I wanted to solve was how do we make this feel less like a one-shot chatbot and more like an ongoing conversation. To do this, I am using LangChain's conversation buffer memory. This stores previous user messages and AI responses so that the system can maintain context across multiple queries. Okay. Now I will talk about why this project deserves to be chosen. This project isn't just about building a tool, it's about creating an AI system for Liquid Galaxy. It acts like a smart layer on top of the Liquid Galaxy system, capable of understanding natural language, generating KML, and automatically visualizing it across the rig. Whenever it's through typing, whether it's through typing or speaking, the assistant handles everything from processing the prompt to rendering it on the screens, making complex interaction incredibly simple. Whether it's for education, geospatial research, or interactive storytelling, this tool empowers people to bring data to life through AI on a global visual medium. Plus, the architecture is flexible. Once it's live, others can build on top of it, adding features, supporting more formats, even plugging in different AI models. That's all from my side. Thanks for listening, and I am really looking forward to building something awesome with the Liquid Galaxy this summer.
Hello, I'm Mohit, and this is the submission for this Build with AI contest for the Kit app. So this is the app that I made for this contest. So as soon as the app is opened, there's this animation that shows on the front page. The first thing that needs to be done is to, of course, uh, connect the app with the LG rig. So here are the five options that needs to be present on the connect tab. The host, port, username, password, and number of screens. There is also scan QR code, which if, since this is not supporting camera, it is not showing it. Uh, when I press connect here, this shows me this connected snack bar. Uh, the user also needs to add the Gemini API key, which he can access by clicking on this I button. So this link will open the page which will give the API key. There's also this tools page which uh, contains all the tools essential for the Liquid Galaxy. So the main page contains this logo, and then there's this input bar. So the main purpose of this app is to visualize the flight paths of various from various cities. For example, if I fly from Delhi to Jaipur.
Ladies and gentlemen, welcome aboard this flight from Delhi to Jaipur. We're just about ready for departure, so please sit back, relax, and enjoy the flight.
So this is showing Delhi, and then it will go to Jaipur. So this is showing Jaipur now, and this is the flight that is orbiting around from Jaipur to from Delhi to Jaipur. So this is a 3D airplane model being that is flying from Delhi to Jaipur, as it could be seen here. This could also so what AI does is AI gives me the coordinates of Delhi and Jaipur. Uh, this could, since these coordinates are given by I could also use something like um, capital of Spain to capital of France.
Ladies and gentlemen, welcome aboard this flight from Madrid to Paris. We're just about ready for departure, so please sit back, relax, and enjoy the flight.
So this is showing me Madrid, and then this is Paris that is showing. And now it will start the flight. So here this flight that is going. It will go all the way from Madrid to Paris. I fast forwarded it. So this could also be used to orbit uh, specific place. For example, if I write here, show me New York.
Orbiting around New York.
So now it is orbiting around New York. So it also contains text to speech, which, as you would have heard, it uh, says after every command. Uh, this could also be used for the normal questions. For example, full form of IP, I could ask it and it would not fly from anywhere. When, just like a chatbot would work. Uh, IP stands for Internet Protocol, just like you said. Yeah. This, uh, this is the information that so another example that we could use is fly from country of rising sun, which is Japan, to country of setting sun, which is US.
Ladies and gentlemen, welcome aboard this flight from Tokyo to London. We're just about ready for departure, so please sit back, relax, and enjoy the flight.
It is not US, it is London. So we are going from Tokyo to London. I could also ask the AI to surprise me, and it would give me two random locations,
Orbiting around Paris.
or it could just orbit. So what I have used as prompt uh, for this app is this. This is the prompt that I have used, and the user input that I give will be added to this prompt and then given to the Gemini API. I have used Gemini API for this, and I have so what the structure of the app is that first the user enters this text, which will be then added to this prompt, this prompt. Then what will happen? It will fetch the API. The API will then return a JSON format like this. You print it somewhere here. It will return some JSON format like this. It will contain the location. For example, if only a orbit is to take, if orbiting is to be done, then it will contain something like this, and it will orbit that. If there are two cities that need to be from and to, so it will respond something like this. So after this is this after this response is given to the app passes the from into location and then creates an orbit from that location to the destination. And then the KML is used to animate the 3D model of the airplane from location to location. So this is the design that I created before making the app. So this is the home page of the app, and this is the connect page that contains all the important text fields. And this is the tools page. This is the animation that I created for this home page. It should be seen here. And this is the this is the animation that I created using Figma, and I implemented it on in the app using Lotus. And this is the mock-up of the liquid galaxy would uh, that what the liquid galaxy would look like. So this is the app with mock-up. Thank you for giving me chance to display my